Hi everyone, let's solve this problem. Validate binary search tree. So given the root of a binary tree, determine if it is a valid binary search tree or not. Basically BST. A valid BST is defined as follows. So all the nodes of left subtree should be lesser than root, and root should be lesser than all the nodes of right subtree. So this is the definition of a valid binary search tree. We can go through the statements. The left subtree of a node contains only nodes with keys strictly less than the node's key. Right subtree of a node contains only nodes with keys strictly greater than the node's key. So basically node is nothing but, let's consider this as a node. They are saying that all the nodes values should be lesser than the node's key. Key is nothing but 2, and for the right they all should be greater than the node's key. That's what they're saying. Both the left and right subtrees must also be a binary search trees. Obviously that has to be the case. So that's the reason we have all of this. So if we take this particular example, okay, 2 is the root node and left is 1 and right is 3. All the nodes are following this condition, so it's a valid BST. So now in this particular example, there is one case which is breaking, nothing but 4. So if you see that 4 value is breaking here, because 5 right should have all the values greater than 5, but it has a 4, so it's not a valid BST. So now let's try to solve this problem. First understand it by using this example. So let's say, for example, this is the root node. What all possible values can be there for a root node? Anything, right? Inside our infinite space, there can be any value possible for the root node, because we haven't had any limit so far. But when I go to the left, what all values are possible? The values should be between minus infinity and maximum should be 5. So they should be between these values. So is it within those limits? Yes. Now let's move on to the right. When I move on to the right, the minimum value will be 5 and the maximum possible value can be infinity. Is it between those limits? No. Because of which this is not a binary search tree. And also we don't have, like, if you consider this particular subtree, this is a valid subtree. But if you consider the entire tree, it is not a valid one, because this particular case is breaking for this subtree. Let's take this example and let's try to understand. So again, the possibility at the root will be minus infinity to infinity, and towards the left it can go from minus infinity to the root value or the node value which we have. Is it within the limits? Yes. Then on further left, I will have minus infinity and 1. Is it within the limits? Yes. Now I'll move to the right side, and here I will have 5 and infinity as my limits. So is the value within these limits? Yes. Now I am moving on to the left. So what will be the limits I have here? Is nothing but 5 and 8, but it is not within the limits. So this node is because of this node, it is not a valid BST. I hope the solution is clear. Now let's try to code it up. So let's say, for example, if there are no roots, okay, we have to also have a function which will take in node, low and high pointers. If you see here, this is low, this is high, which we have a range of values in between which the node value should fall in. So I will have low and high. So how will I call this? I will first call this as valid root, and low will be minus infinity as we discussed, and high will be infinity. Now when I am validating this, if I get a node which does not, it's a null and does not have any value, then it's a valid binary search tree, right? Because there are no nodes. After that, what should I do? Once I get this value, I have to check if node low is less than node dot value and node dot value is less than high, right? But if this condition is not matching, it means it's not a BST. So I'll return a false from here, and I will validate the same thing on node dot left subtree and validate of node dot right subtree. Now let's understand how we are passing the values. So in this case, we are passing low as it is, but for the high, we are passing node dot value. So for the left subtree, we are passing the low without any changes, and for the high, we are ensuring that it will be the node dot value. Here the node dot value is 5, and that's the reason the range for the left subtree will become minus infinity to 5. And similarly for the right subtree, node dot right, here the left or the lower range will change and higher range will be passed it as it is. Now I will have to return it. Why do we need a AND condition here? Is because we will have to have a valid trees on both the sides. Only then it's a valid BST. So now let's try to run this solution. Yes, let's submit it. Nice. So also let's understand the time complexity of this solution. Time complexity is big of n, because at max you are iterating over every node once, so it will be big of 1. Space complexity will be, worst case it will be big of n, because if all the nodes are on the same tree, on the same side of the tree, then it is a skewed tree which will have a big of n recursion space. We are not using any additional space apart from, like, we are not even using any variables here, so it is big of n just for the recursion space here. I hope the solution is clear. Thank you.